Hello and welcome to another one of these ADD videos. Today we're going to be looking at some examples of multiplying algebraic expressions. Recap the properties real quick. If we are distributing something, what we're doing is we're taking each one of the terms inside the parentheses and multiplying it by the term outside the parentheses, whether it's 2 terms or 3 terms or 10 terms. And then if you FOIL, it's first, outer, inner, last, or you can use that little Punnett square, the little table there. If you've got a perfect trinomial square or something squared like that, it's always a square of the first, square of the second, and twice the product. Anything greater than 2, you're going to need to use Pascal's triangle. I'm not going to deal with that on this video. That will be on the more advanced videos. Okay. All right, so on this one, let's look at these examples I have written down. First one is an example, hopefully, of, again, on these example videos, make sure you just pause the video, see if you can do the problem before I go through the solution. So here, if I take the 4 and I multiply it times both of these, let's go ahead and switch to red. You're going to get a 12x plus 8. And there's no like terms. This is an x term. This is a non-x term, so we're done. Wasn't too bad. Let's look at this one here. We got an x in our term we're multiplying through now. So again, we're going to take this whole 3x times both of these. So the first one's going to give me 3x times x minus 3x times 2, which gives me 3x squared minus 6x. This is a common thing you will see in algebra, pre-cal, or even calculus. These two terms in the first spot are the same, x and x, and then the second spot are the same, y and y. The only thing differing is a plus and a minus sign. And what I'll do is I'll go ahead and FOIL it out for you and show you the steps. So this is x times x first. The outer would be plus xy. And then I'll explain to you that anytime you see that general pattern, you can recognize it as something called a difference of 2 squares. And then minus y squared. And what will always happen here is that middle term, one will be a positive and the other one will be negative of the exact same thing. And you'll always be left with the square of the first and the second with a minus sign between. Hence the name difference of 2 squares. So if you see a difference of 2 squares and you want to factor and you want to go backwards, it's always just take the square root, put a plus in one and minus in the other. Okay? So we will see that again. Here we have a perfect trinomial square. You can go off to the side and FOIL it out and rewrite this as 3x plus 1 times 3x plus 1. And then do the first, outer, inner, last. So in this case, it'd be 9x squared plus 3x plus 3x plus 1, 9x squared plus 6x plus 1. Now, the easiest way to do it in my eyes would be to square the first term. This is the shortcut I showed you. And then plus square of the last term. And then plus twice the product of the 2 terms. Using Pascal's triangle indirectly, but just looking at the pattern. Then you're going to get 9x squared plus 6x plus 1. And most people can do this step in their head. But before you start doing stuff in your head, make sure you're really proficient. And even then, it's a good idea to show your work. That way you can maybe get some partial credit. So here we've got another distribution scenario. So we're going to take the 2x times each 3 of those. So we have a 2x cubed minus 4x squared plus 6x. And you're done. Okay? So be on the lookout for little patterns, little things that it can help you on a time test. Will always be beneficial. All right? I hope I've cleared up any confusion you might have over the fundamentals of multiplying these algebraic expressions. Remember to practice,